Previously, I've talked about particles found in atoms and their interactions. In this video, I will introduce particles that create a phenomena similar to electricity, the positive and negative Freesmart particles. A Freesmart is repelled by Freesmarts of the other type, and Freesmarts of the same type don't interact, and they also interact with atomic particles, such that there are atoms that attract Freesmarts and others that repel them. A Freesmart wants to go to an atom that attracts Freesmarts, called the attractor, while avoiding particles that repel it. When a Freesmart reaches the attractor, it gets converted into light, and the color of the light emitted depends on the kinetic energy of the Freesmart. It's possible that the opposite is also true. When light collides with an atom that repels Freesmarts, that light is converted into a Freesmart. This is called the light-Freesmart equivalence, which could be used for wireless communication. These particles are not attached to an atom, so they are free and they know how to get to the attractor without being close to particles that repel them, so they are smart, hence the name Freesmart. The energy that a group of Freesmart particles carry is the average kinetic energy of the Freesmart particles times the number of Freesmart particles. And power is the product of the average kinetic energy by the number of Freesmart particles that pass through a wire per unit of time. You can think of the average kinetic energy, number of particles, and number of particles per unit of time as being similar to the tension, charge, and current respectively. However, the analog to resistance isn't so similar. There are particles that attract Freesmarts and others that repel them, but think of a Freesmart encountering matter that repels it. Initially, its speed decreases, and if it's too small, it can start to go backwards, so there is no current. However, if its speed is big enough, it can pass the repelling matter, but when this happens, the repelling matter is going to push the Freesmart away from it, which, now that the particle is on the other side, is in the direction that the Freesmart is traveling at, so in the end, the Freesmart speed didn't change. If we consider matter that attracts Freesmart instead, the speed of the Freesmart increases initially and then decreases. At the end, it is the same. However, a Freesmart will always be able to pass attracting matter, since it gains speed before losing it. Note that what actually changes the speed of Freesmarts is the difference in attraction, and not the absolute attraction between the Freesmarts and the surrounding matter. If a Freesmart is completely surrounded by matter that repels or attracts it, it won't change its movement, since the forces that are applied on the Freesmart particle have different directions, and their effect cancels out. A Freesmart's kinetic energy can only permanently change this way if the matter surrounding it changes permanently. There are other ways to change a Freesmart speed, like this motor. It's a wheel with weights and the Freesmart particles have to push the wheel to get to the other side, transferring kinetic energy from the Freesmart to the motor, making the motor spin and the Freesmart slow down. It's also possible to make logic gates. If the only path that a Freesmart particle has to the attractor is blocked by Freesmarts of the other type, the Freesmart will not go there. With this, we can create ternary logic gates. The I's are inputs and the O's are outputs. The lines are wires, and in the cross gate, one wire is on top of the other. The Freesmart can't go from one wire to the other, but if two wires have different types of Freesmarts, they will stop because of their interaction. These are the truth tables for the cross and merge gates. A plus represents a positive Freesmart current, a minus represents a negative Freesmart current, and N represents no Freesmarts. We can combine these logic gates with sources, represented by S, that always output particles of the same type to create binary logic gates. Inputs, outputs, and sources with a subscript can only input or output Freesmarts of the type of the subscript or nothing. But since these logic gates are type symmetric, the type of the Freesmarts doesn't matter, only the relationship of an element having the same or different type. I also made this logic gate that can convert Freesmarts of one type to the other, so it's possible to make a binary computer. It's also possible to make a ternary computer. Here are the negation and minimum operators of post-ternary logic, which are functionally complete, meaning it's possible to make any ternary logic gates using only the negation and minimum operators. This means that my cross and merge gates, combined with positive and negative sources, are also functionally complete. Before I end this video, I would like to say that there is no evidence that free smart particles exist. They are just things that could be useful to explain how some machines work. I am calling theories like this leaps of faith. However, since it's impossible to make experiments, it's impossible to disprove leaps of faith unless the leap of faith contradicts things in the BFDI. And since experiments are impossible and BFDI features technology, I think it's necessary to make some leaps of faith to explain some things. This is all I have for this video. Goodbye.